Well, good morning, everyone. Is everyone as excited as I am to talk about the art of building framework-independent design systems in a dynamic e-commerce enterprise? Very good, very good. All right, allow me to introduce myself. My name is Stefan Nieuwenhuis. I'm a software engineer and developer advocate at the largest online retailer in the Netherlands and Belgium, bol.com. I have a master's degree in archaeology, love to play water polo, love to read books, and I occasionally jump out of planes, with a parachute that is. And as I said, I'm here to tell about the art of building framework-independent design systems to maintain consistency throughout a very complex, huge enterprise applications. And before we start with a deep dive into all the technological stuff, let me provide you some context to give you an image about the company I work for. It all started back in 1999. We started as a web shop for selling books and CDs, and soon we start expanding our assortment. For example, with electronics, DVDs, mobile phones, you name it. And up to a certain point, we came to the realization that we couldn't cope with demand anymore. So from that point, we've decided to open up our platform to external sellers and welcome them to add and to sell their assortment via our platform as well. And it was actually quite successful because 2 years later, we reached the 1 billion turnover point. But unfortunately, the seller's assortment didn't appear magically on a web shop. So we had to provide them with tools and everything necessary in order to accomplish that, in order to put their assortment successfully on our web shop. And therefore, we started developing a retail tooling platform that contains all the tools that the sellers need in order to do so. And a small team started developing that, and it was basically a startup in the company itself. And with a true startup mentality, they started building the application as a monolith. And the monolith consisted out of a server-side app, and the server-side app contained all business logic. There was a user interface, of course there was, that enables the sellers to interact with the system, and there was a database to store the data as well. And some of you might consider, even back in 2011, that a monolith is a relic of the past, an outdated infrastructure. But it actually makes sense to start developing an application, a small-scale application, with a small team as a monolith. And why? Because a monolith contains less cross-cutting concerns. All components, because all components like testing, logging, and monitoring modules are contained in one single application. You also have less operational overhead because of that. And in some cases, it can be quite performant because every component in that application has access to the same shared memory. And then it can be quite secure as well, because you only have to monitor and basically secure one application. And planning and designing new functionalities is quite straightforward. As I said before, it's, this monolith architecture works pretty well if you have only one team and if you have a small-scale application. But if the number of teams are growing and the complexity of the application grows as well, all those advantages of a monolith suddenly turn into disadvantages, because you have to take in, all the teams that are currently working on an application into consideration, and complexity has its impact on performance and security. For example, a complex application introduces many more bugs, so that form potentially a security threat to your application and to your IT landscape as a whole. And planning and designing new functionalities for a complex application and an application where everything is basically intertwined, yeah, that's awful. So in order to scale it properly, we figured out that we have to change our approach of developing our applications. Enter microservices. Microservices basically provide us with a complete different approach to developing applications, because a microservice application that consists out of microservices is basically a huge application that's split up in tiny different parts of business logic. Microservices are very scalable because every service contains a small part of the business logic or a small part of the user interface. So, for example, if you need a monitoring module, well, you basically create a new microservice for that. If you need a login screen, for example, well, just create a new microservice for that. Microservices are independent as well. And what I mean with that is that, yeah, every service, every micro frontend is basically an application, a standalone application on its own. And yeah, therefore it's quite independent, and therefore you can assign multiple teams to multiple services. And then transparency, because transparency because all services contain very small parts of the business logic, and therefore it becomes quite transparent. But same as we saw earlier with monolith architectures, when the number of teams grows and your application landscape grows, all those advantages can slowly turn into disadvantages as well. And then we have the problem of consistency, because the independent nature of microservices and micro frontends in particular causes teams to communicate less with each other. Everyone is sitting basically on their own island, and yeah, they're basically maintaining their own applications and sometimes forget to communicate with each other, which is terrible for the consistency. So, how to prevent this and how to maintain consistency in a microservices landscape that in total form huge enterprise applications? Well, our answer to that is a so-called design system. We figured out that we basically need a good set of rules, a good set of agreements, and reusable components that are accompanied with those rules. Yeah, and why do we need that? Because all teams, were basically reinventing a square wheel over and over again. One team was creating an interface for a product overview, for example, and created a nice, neat little list page. And the other team was basically doing the same, but then with a different look and feel. And that is terrible for the consistency of the application and the usability and the adoption rate of an application as well. And, well, as you might all know, if an application is not being used, you're quite in a pickle. So what's a design system? Well, a design system is basically a collection of reusable components accompanied with a clear set of rules which you can use to create any number of applications. It consists of a pattern library, a so-called style guide, and a components library. What is a pattern library? Well, in a pattern library, you basically describe the behavior of your components. So why can I use a primary button here? Or how do I use a list overview page? That is all contained in a pattern library. And a style guide is basically a visual language of your application and of your brand as a whole. It describes the do's and don'ts for developers, for UX designers, and for users for an application, and basically for your brand. And here I added some SAS variables, which define the corporate colors and the secondary colors. And if you hand this, it's basically a contract between a UX team and the developers. If you hand this so-called contract over to a development team, they are aware which colors they can use to implement in their applications. So this is quite an important part of your design system. And last but not least, we have the components library. And before I dive deep into our components and what a components library is and how we implement it, let me explain some earlier attempts we made before. Back in 2011, AngularJS was for us the way to go. Every team was developing their front-end applications with this particular framework. So it made complete sense to us to build our design system, our components library, because back then we didn't have a design system, we only had a components library with this framework as well. But then, bam, Angular 2 happened, and yeah, as you might know, it was completely breaking, despite the name, the similar name to AngularJS. So it was completely breaking, and yeah, teams slowly were adopting it, and it seems to be that it was the way to go, and AngularJS was more and more considered as a legacy application. So what we did was basically porting our components library to Angular. So suddenly we had to maintain 2 components libraries and keep them in sync as well. And then other teams started experimenting with, for example, React and JavaScript. And yeah, then we realized that we had a huge problem, because eventually we had to support them with a port of a components library as well. So we realized that we really had to break out that vendor lock-in. And how do we break out of it? How do we break out of it? With web components. Web components are basically custom HTML elements which you can create on your own and which are natively supported still with every browser. Most of the browsers, except for Chrome, are supporting it with polyfills, and Chrome is basically the only browser for now that supports it completely natively. But in the upcoming years, it's quite clear that all other browsers will follow. And with web components, we're extremely flexible because we don't have to worry about framework lock-in. So even if you're still using AngularJS, you can use the components in the components library. Well, there you have it. All the components are quite reusable, which means that most of our applications which are adapting our components library can have a generic look and feel to it. But as always with something good, there's quite a downside to it as well, and that's the development speed. Because web components, if you want to build web components from scratch, there is a very steep learning curve. And let me explain to you by an example. Here we have my awesome button, and it's basically a huge red button, which does basically nothing. It's a very simple hello world, my first web component example. And how do we make this? Well, first we start building an HTML template. We use the template tag for that. And I decorate it with an identifier in order to access it later via our controller. Then I add some basic styling to it. And last but not least, for regarding the HTML template, I add the actual template in it. And if you look at this code, you see that you don't have a real separation of concerns. Styling and HTML templating is all confined into one HTML tag, basically in one HTML file. Next, I have to create a custom class, so-called myButton element, which extends the native HTML element class. And notice the super keyword in the constructor. I need to call the super or the parent class in order to establish the proper property chain, and hence the super keyword. Then I have to refer to the template created earlier by a simple document.get element by ID. And then I have to establish the shadow DOM and have to append a clone of the HTML template as a child to the shadow root. So there we have it. And last but not least, I have to register my custom element to the custom elements registry with a define function in order to use it throughout my application. And then the circle is complete, and there we have our button component. And as you can see, it's quite some. It took me quite some time to basically scaffold a basic web component, because we didn't take events into account of property exchange, whatever. And so it was quite a hassle to put this all in place already. And this is even without a professional development environment. And we didn't think about testing yet and handling polyfills, for example. So yeah, that was quite a problem for us, because if we want to create more complex components, it will take us basically forever. So it was back to the drawing board for us, because we were really convinced to use web components, but yeah, we had to find a way to increase development speed, and we found our answer in the form of Stencil.js. Stencil.js is basically a web components generator, which generates 100% natively supported web components. It's very performant. It has a very straightforward API. It's future-proof because of web components. It's compatible with all major frameworks out there. And well, let me show you how to create the same component, but then with Stencil.js. Well, Stencil.js comes with a starter, so the first thing we have to do is to open up a terminal window and type in npm init stencil. And then this dialog will start popping up. I hope you can read it, because it's quite dark. But yeah, we pick a component, and then in only under 4 seconds, 3.82 seconds to be precise, we have a professional development environment set up with testing included, and we've scaffolded our basic web components code. And this is how it looks like as a folder structure. So now we're ready to start building our components. And here, and therefore we need to access the controller. Well, here it is, and it looks quite similar to an Angular component, or a Vue component, or a React component. So it's very recognizable for all the developers that actually building web components in Stencil. So now we only have to change our tag, the style URL, and the class name, and add our HTML template to the render function. And there we have it. We're done developing our nice, awesome button. And in order to use it, now we're opening up the terminal, type in Npm Run Build, and a build will start. And well, it basically does lots of stuff for you, which you don't have if you're building web components from scratch. Because, for example, it's transpiling the code, it's generating styles, it's mapping, it's bundling, and it even generates custom documentation for you. And here we have it. If we're done building, you have a nice, neat little folder with all polyfills in it as well, which you can actually use in your application in this way. And there we have it. And I think this, well, costed me like 10 minutes to create. So if you compare it on the hand of the time that it took me, Stencil.js is definitely the winner. So now that we know how to build our web components, we need to find a way to store them efficiently. And we really want to publish our web components separately, so we can save our web components in separate repositories. But then, yeah, you basically find yourself in maintenance hell. So we followed the example of the big tech companies like Google, Facebook, and Twitter out there, and start building. Oh, sorry. This is a summary of all the things that we have with Stencil.js. I completely forgot about it. Sorry about that. Yes, Stencil.js provides us with an extensive config, with bundling, an out-of-the-box professional dev server with testing in it, typed components. It generates documentation automatically for you, and enables us to use plugins, for example, Sass and polyfills. Okay, back to the mono repository. Yeah, a mono repository contains one single source of truth. Yeah, it's reusable, of course it is. Versioning, it's scalable, and it's backed up by the big major tech companies out there. So this is how our mono repository, or actually part of our mono repository, looks like. With a folder with bricks, and yeah, it contains all the components out there. And we want to publish them separately to our internal npm repository. Yeah, because we want to save the developers from the hassle of importing a complete library when they only want to use one or two components from the components library. So that's why we want to publish them separately, but that introduces quite of a hassle with managing all the packages. And therefore, we use Learner.js, and Learner.js is basically a package versioning manager and publishing manager, which takes care of that for us. So, and this is how two components configurations look like. And with Learner.js, we can actually use scoped packages. And scoped packages is, for example, if you look at both configuration examples, is that we can use a prefix for a components library. So this will help us, for example, with naming and confining our components library in the already complex and crowded npm repository we have at our company. Then we can use semantic versioning as well. Learner will take care of that completely. So that's awesome. And you see here that the buttons component has a different version than, for example, the footer component. So it makes us completely flexible, and that's really awesome. And then, yeah, it allows us to don't have any interdependencies between the components, so they really stand alone. And it makes us extremely flexible as well, because if we want, for example, add an icons component to it, well, it's as easy as initiating a new stencil component and add it as a folder to the mono repository, and then we can build it and publish it. And there we have it. So now that we know how to create and store our components in an efficient way and a very flexible and neat way in our components library with a mono repository, we have completed the circle of a design system. And a design system is, for us, a very good way with the style guide, with the description of the components and the do's and don'ts, in a pattern library and the components library itself to maintain consistency throughout the complete application. But it's not a holy grail of consistency, because developing applications is still, yeah, a human job. So you have to communicate, and you have to get, especially when you have to take business stakeholders, UX teams, and developers teams into consideration, you have to get on the same page and you have to speak the same language. So although it's not a holy grail of consistency, I think it's a really great tool to help all people to get on the same page and to talk the same language. My name is Stefan Nieuwenhuis, and I hope that you really enjoyed my talk. And, well, I'm on Twitter, and DMs are open. So, yeah, I would like to thank you very much for your attention. And have a great day. Are there any questions? Yes. Very good, very good. Yeah, that's always the issue, especially when you have different versions of components and different versions of yeah, basics like colors. So yeah, that's the communication part, because yeah, you can publish a new version of those colors into your components library, for example, or into your style guide, but you have to notify and you have to make all the development teams, because yeah, they're basically implementing it, that the new colors are out there. So I think, to answer your question, that knowledge sharing is key. So yeah, you have to inform them via weekly newsletters to inform them about breaking changes, because a change of colors or a complete design change is, to me, I consider that quite a breaking change. Yeah, and you have to basically, yeah, inform them via knowledge sharing and knowledge sharing sessions.
So there will be, so if they're informed and they're taking action, there will still be a little bit of the transition period when you will have a little bit of inconsistency.
Exactly, exactly, and that's always the challenge. And yeah, we don't have a clear answer to that, except for yeah, information helping each other with it to prevent or to take care of that transitional phase to be as little as possible. Yes.
How do you solve inter-component dependencies? For example, if I have a button who needs a mutation observer fully filled, and another component which needs the same fully filled, do they bring their fully fills each, or do I load it once?
Very good question. Well, Stencil.js will handle that for you. So you basically don't have to, well, yeah, exactly. You have two components which have all the polyfills included. But if you, stencil components are smart enough to know that polyfill is already there. And it depends on which framework you're using to, for example, Angular does something with tree shaking and with bundling and packaging your modules to, yeah, to take care of that as well. Yes.
Yeah, so in general, what is your approach of integrating all the microprojects? So do they really just deliver every microservice in independent frontend, or do you have situations where one team is maybe responsible for a component in a website and use an approach like yeah, scissor and paper for some else? What's your approach?
A very good question. Yeah, currently we have yeah, a retail tooling platform, and that retail tooling platform is basically divided in all kinds of small applications. One is for product overview, one handles the login page, for example. Well, you name it. And for every small part of that application, a team is responsible. So it could happen that a team is responsible for a small part of an application, but yeah, normally, no, we have a strict division between all those parts.
So the product team delivers the complete page.
Exactly, exactly, yeah.
Did you solve the typical things like sharing the same main navigation? Like, so every team has to rebuild the content of that navigation? Or?
Yeah, that's a good question. Yeah, we have a native web component for that as well. So we have a standard menu component, but yeah, every team has to implement that and configure that as well. But it's connected to a so-called menu service where all menu information is stored.
Okay, so you solve it kind of through composition, so every team needs to then connect to this menu server when they deliver the complete website.
Exactly, exactly. Yeah. Any other?
Do you have a dedicated components team, or is every team contributing into the repo?
Great question. Yeah. Sorry for my hand. The light is very bright. No, doesn't help. Yeah, we have a dedicated core team that actually maintains the design system, the technical part of it, and yeah, defines the architecture. But we really want to enhance the community of developers inside our company to collaborate with us with that core team. So yeah, in theory, in our company, all those development teams that actually use the components library are contributing to that components library as well. But yeah, the basics are being built by that core team. So yeah, it's actually an open source initiative inside the company. Does that answer your question? Great. Yes, sir.
Interested in the journey you did to the end state you just presented.
Yeah.
Did you start off with the old system, including separated components from the beginning, like the full architecture, or was it iterations to get there from one big thing?
I could talk on that for hours and hours, but yeah, let me give you a small summary. Yeah, it was just a huge journey with several attempts, and yeah, we tried, for example, that example that I give with AngularJS. Yeah, that was an attempt to create a full cover design components library, but yeah, we failed, and then we learned from that and took all those lessons, and we started basically a new initiative, and yeah, that failed again, and now we're here. So yeah, it was really stepwise, yeah. But if you want to learn more about that, we can meet after, and yeah, cool. Are there any other questions? Then I would like to thank you very much. Oh, sorry.
I have a small question. You mentioned monolithic repository. Do you mean monolithic repository only for components, for web components?
No, a monolithic application in the form of a retail tooling platform.
So the whole application is monolithic?
Yes.
And the components are part of it, or are they distributed separately?
No, that was when the teams the number of teams started to increase and the complexity of that monolithic application increased. There was a growing need for a components library to share, functionality between those teams. So we already had a microservice architecture in place, and the monolith was long ago. And then, we found the need to have reusable components. Well, I would like to thank you very much and have a great day out here. And thanks for your attendance.